Hi, everyone. Let me show you some output of this two program. First, let's check this one. See, this is the original image. You can clearly see this original image. And this is the output of this program, right? You can clearly see one outline inside this particular object, right? Okay, let me show you one more program's output to you. Before that, I have to close it. Okay, check this one. So this is Lina. I hope you all know this Lina image. And this is the output of this image. You can clearly see this outline, this edge in this particular image. So edges are clearly detected, right? Yet means what we have to means find out from this image that how the objects being isolated from the particular image, right? This is the our object and we have outlined this object. Well, so how we have done this? This is the main objective of this class. I'm going to teach how this thing's being done and what is the means Python implementation of this program. Well, you are with Dr. Dibbas Dibora. Let me start the class then. So this thing that I have just shown to you is known as morphological gradient. Means one operation is there that falls under morphological transformations. And this, because of this operation, morphological gradient, you have just seen the output, what I have shown to you. So what is morphological gradient? Sorry, in mathematical morphology and digital image processing, a morphological gradient is the difference between the dilation and the erosion of a given image. Just if you have attended the last lectures, then you got to know that what is dilation and what is erosion. Please go through it if you have not already attended those lectures, right? I'll also give you the links below. So you got it that morphological gradient is the difference between dilation and erosion. It is an image where each pixel value, typically non-negative, indicates the contrast intensity in the close neighborhood of that pixel. During the dilation operation, additional pixels are added to an image boundary, and during the erosion, what happens? Additional pixels are removed from the image boundaries. So you remember that in the case of dilation, we have our foreground object thickness increase, right? The thickness of the foreground object is increasing in the case of dilation operation. But while in the case of erosion operation, the reverse thing happens. So why? Because additional pixels are added to the image boundary in the case of dilation, and in the case of erosion, additional pixels are removed. The total number of pixels added during the dilation process depends on the dimension of the structuring elements used. Okay, for that I have already told you that how the kernel is being selected, and means there are different types of kernel as per our needs. Now, morphological gradient is the operation that is equal to the difference between this dilation and erosion. Each pixel value in the resulting image indicates the contrast intensity in the nearby pixel, and obviously we can go for edge detection, segmentation, and to find out the outline object with the help of this morphological gradient. Now, if we go for implementing using Python, means in OpenCV, then we have to use this particular function. First, CB morphological X, this function we have to use for the morphological operations, and under that, cv.morph gradient. So morph gradient is the function, morph underscore gradient is the function which will perform this morphological gradient for that image that you will pass in this particular function. Here, suppose this IMG, this is the original image, comma, cv.morph gradient, comma, kernel that we have defined, right? So gradient is assigned a value of CV, morphological X, image CV, morpho gradient, kernel. Now, as you have got it, that what is morphological gradient, how these things happens, and what is the function that we have to use in Python to implement this. Now, let's come back to the code again. Now, look at the code very carefully. If possible, take a screenshot of this program. Import CV to SCV as we are importing OpenCV, who is one instance as CV. Then import numpy as NP because we have to define the kernel, right? So that array-based operations we have to perform with the help of numpy. Now, this is the location of our original image, keeping it in IMG. Kernel NP1's dimension 5, and NP UINT8. Okay, integers. So 5 cross 5 dimension kernel we have defined. So all the values are 1. Then gradient cv.morphology.ex image. This is the original image, right? Then this cv morph gradient. You have to remember this function cv dot means under the cv we have used this function morph underscore gradient comma. This is the kernel, right? Kernel as we have already defined here. Okay, then let's show the original image here, and then let's show the gradient version of it. Okay, CPU wait key 0, so that if we click the close button, then the window will be closed, and CP destroy all windows so that the memories will be released, right? Well, now you have got each and every line of the code. So let's just implement this. Okay, so for that, just click this. See, well, first I have to show you the original image. This is the original image. You got it? This is the original image. And this is the gradient image. So gradient image, we have got what first dilation operation happen. For that, whatever, and that extra pixels are added to the boundaries, right? And for after that, erosion happens. Erosion happens means extra pixels are removed from the boundary. Then that dilation minus erosion is what we have got as the output of the gradient. So I hope that it is very much clear to you now. So let me show you the same program for a different image for Lina, right? See. First, I have to show you the original image. This is the original image in gray version. Obviously, I'm taking the color version, but I have converted it into the gray version. And after converting it, same thing, we have defined the kernels of 5 cross 5, and then we have performed the gradient operation here, and we got this image. You can see the gradients, mean the edges are clearly detected for this Lina image. So you can utilize this code for various operations. Suppose you are going to have some segmentation output for your images, means you can perform segmentation, you can perform edge detection, or you can perform object detection in an image. So for these things, you can go for applying this particular code, for applying this particular morphological gradient operations. I hope I am very much clear what we have means discuss, and I hope you have got everything. Still, if you have any question, then don't hesitate to ask me for comment. That's all for today's session. Thank you.